Welcome to the Elevate the Edge podcast. I'm Maribel Lopez of Lopez Research, and I'm joined with my co-host Joe Peterson of Clarify 360. If this is your first time listening to the podcast, welcome. Elevate the Edge is published bi-weekly. The podcast focuses on helping companies understand what edge computing is, how the market will evolve, and what you need to know to build successful edge computing strategies. Show notes and subscription links can be found at elevatetheedge.com/episodes. We hope you'll enjoy the show. Hello and welcome back to the podcast. I'm Maribel Lopez and I am joined here with my fabulous co-host Joe Peterson. Hey, Joe.
Hey.
Okay, once again, we're always excited to have guests and we're always excited to talk about the edge. But we are here today with Dan Bogdanovic. He is the CTO of Alef. And as I said, we're Maribel and Joe. And today we're going to spend some time talking about vRANs, private edge, and what's going on in modern edge networks. But before we do that, I thought I'd just spend a minute talking about Dan. He is a seasoned technical executive with more than 25 years of experience in high-tech environments. Like many things in edge, in order to be a CTO, you have to really have a proven track record and sophisticated solutions. And many of the people we talk to, including Dan, have both a startup, mid-sized through large global telecom sector background. So he has had expertise in new solutions building, prototyping, product plans, revenue opportunity analysis. So we're excited to talk to you today, Dan.
Thank you for inviting me.
Now, I threw out some interesting terms at the beginning of the introduction, and for those in the audience that might not be familiar with the term, could you spend a moment describing what vRAN is and why it's an important part of edge technology?
So vRAN is a virtualized radio access network. If you look into any mobile network, it has three major subsystems. One is the radio network, one is the transport network, and one is the core network. The radio is the most distributed part, and all those antenna towers that you see throughout the city or throughout the when you go out in the country, that was hardware dominated, and that was quite expensive to build. Software-defined radio started in about 2000s, about 20 years ago, and the radio access and the RAN, radio access network, went from a hardware to a software subsystem. As it's highly distributed, it means that the parts, the software parts, cannot run in a centralized location. They have to be distributed around the country in order to be able to send the signal to the antenna for the broadcast. So the edge is really important for the vRAN because it enables the vRAN deployment in modern times, lowers the cost of the operations as well. It makes it much more easier to upgrade the networks, the radio networks, to a new generation of technology.
So in some ways, it is similar to what some organizations have experienced when they were looking at virtualization. This is a way of thinking of virtualization for a comm-related industry. And you mentioned the term software-defined and how we've been working with software-defined for quite some time now. When you look at it, do you think that there was any specific new way of thinking about it or breakthrough when we think of vRAN?
Well, the first software-defined radio was started to show up in academia at the end of the previous and the beginning of this century. The software-defined radio is actually software-defined networking is a term that AT&T coined, I think in the 70s or 80s. And then it has been sort of in the academic environment has been around, but it really became popular in the past 10, 15 years. And now we are getting into everything software defined. But in the vRAN case, it's about software defined radio and how software can modulate the radio signal instead of hardware doing that. So this is the Mark Andreessen. He said software is eating the world, and in a certain way, it is, because because of the increase in compute power, we can turn to what was previously built with hardware. We can build that more and more in software on a not completely general purpose based hardware, but on a highly you can use multiple applications on that type of a hardware. It is not just for one thing. So that's the beauty of the compute that we are building, that the hardware vendors are building, and then we can run different types of software on top of that hardware and getting results that we need, that for which before we had to do everything in hardware.
See, I thought a little bit of a look back and where we are now was important, because sometimes when I think people hear software defined, they're like, well, is that really new? But to your point, if you couple it with some of the concepts of, we went from highly specialized hardware to now it's not quite commodity hardware, but we can do a lot of different and amazing things in software. I'm going to kick it over to Joe in a minute, but before I do, I wanted to ask you one more question. So according to the Global Mobile Suppliers Association, there are 748 private network deployments in enterprises as of roughly January of this year. So it's obviously increasing in deployments, and we don't know the exact number, but that's one number that's been thrown out there. But I'm wondering, from your perspective, what are a few of the reasons companies are moving towards these private network deployments?
They need deterministic mobile connectivity. They need reliable mobile connectivity that they are fully controlling. Why do they need that? Because they are trying to do an industrial application that cannot be tethered. Most of the robots that we are seeing in deployments today, they are wired. And the application developer for that robot decides how data has to be treated. Some data has higher priority over another data. And usually they classify data into three buckets that has a hard limit, firm limit, and soft limit. If the data has a hard limit and it does not arrive within that time limit, it can cause you a catastrophic event. So some data cannot be lost and some data can be lost, or it can be delayed. It's not important. And the application developer is the only one that knows that. The network provider cannot know that. So the person that has to be in charge of the connectivity is the application developer. It has to say, I need this type of connectivity. On wired systems, that was easy. But on wireless system, that wasn't easy because Wi-Fi does not provide built-in mobility. Wi-Fi and IP technology in general don't have mobility in the architecture. So it always has to be somehow a workaround. And the only people that figured out the true mobility are the 3GPP folks. So now there is a question how you can bring in mobile network into the enterprise where all of the control over that connectivity is within the enterprise. And the private mobile networks are enabling the enterprises to do that. You cannot go to Verizon and say, I want to change all these parameters on your network according to my needs, and I want to do it at this high level of frequency. Because Verizon is not set up to do something like that. They are set up to manage large number. They have few groups with a large number of members of that group. There are different types of subscribers that are managing it. At the enterprise, you would have what can be a very large number of groups with a small number of members in that. You can have one specific application, but they can be running 700 different applications. So that is the difference how the systems are set up. And from a management perspective, it opens up also complexities and security vulnerabilities if Verizon would open up their network to the enterprises fully, as well the other way around, if the enterprises would allow third parties to come in and try to change things inside there. Because enterprises want to keep their enterprise IT domains highly secure. And they want it to run within their security parameter with their security policies. And they are much easier to manage and deploy and enforce within a private network than through a third-party carrier.
That totally makes sense. As I'm listening to you, Dan, I'm wondering if I'm getting my own terms straight here in my head. So maybe you can clear something up for me. Is a private network deployment the same thing as a modern edge network? And if it's not, tell me how they're different and tell me what might make up the piece parts of a modern edge network.
So first of all, edge is a highly fluid term. Edge is wherever the application needs it to be. The edge can be, when people talk about self-driving cars, the edge can be inside the car because you could have 100 computers inside the car and they decide there will be an edge within that car that is controlling those 100 computers inside that car. But an edge can be also in a metro area for something else. So the edge is when you're building new applications, those applications are being built from multiple components. You cannot run everything on a single PC as we are used to. Today, when we use a laptop or we use a mobile phone, only a little piece of the logic is running locally on the device, and many things are running centrally in the cloud. So a single application like what we are using now to record this, I wouldn't be surprised if this has been generated from about 30, 40, or 50 different containers that have been put together in order to give us this presentation. The presentation is being done locally on our side, but the computational part is being done centralized. Now, going back and forth takes a lot of time, and they're saying not applications are that latency tolerant. And different applications have different latency requirements. If you go back to the hard, firm, and soft data limits. And they're saying, I need some things to be centrally computed. But then I will send that data that is centrally computed to an edge location where my applications that are controlling my robots will be using it according to the local condition. Not every robot will be facing the same local condition. And for that robot to be able to calculate the right action based on the local conditions, it cannot always go back to the central location. It has to go to somewhere nearer, and there will be some logic working that will be doing that translation between the highly centralized to a more distributed view. And then the hyper-local view will be enforced by the robot. For example, if you have a number of autonomous forklifts inside a warehouse, you can have a single centralized application that is building the routing topology and how to do that optimization. And they're sending it locally what algorithm they should use to run it inside the warehouse. But some warehouse can have five forklifts, and another warehouse can have 30 forklifts. So the edge location will translate that into a warehouse with 5 forklifts or with a warehouse with the 30 forklifts. It will be differently applying it based on the local conditions. And then each robot, each autonomous forklift will then implement that data even further based on its very local condition, where it's exactly in the aisle, what floor is it picking from the shelves, etc.
That makes sense. Thanks for explaining that. Maribel, over to you.
So if companies are thinking about moving to a private network, what are some of the things they should be thinking about from a strategy perspective?
Oh, that's a very loaded question. So from a
They're all
strategy
different, right? All the different private networks, different industries, different
different industries. So it's really, but for them, it's how simple, but I don't want to oversimplify it. What is the easiest way to deploy and manage that private network? That should be for them the main question, because they are not a networking company.
Right.
Private networks are there to support their main business objective. They're not a network service provider where network is the main thing that they're selling. Private networks are there to support other business activities, and for them and for the enterprise IT administrators, the important thing is what is the easiest way to deploy, manage, and making sure that it doesn't breach their security, in general, that doesn't breach their enterprise IT policies. How easy is to extend those enterprise IT policies into that new access technology?
I know Jo wants to ask you about security. I can just tell from the look on her face. But before she does, I guess I just wanted to make one comment, and that's around, I think people have underestimated how difficult it is to actually build a network. It's particularly if you've done lots of wireless LAN stuff, I think you really associate it as being similar, and they're quite different. So there are many different things to think about. That doesn't mean that it's not relevant and that you can't do it. It's just figuring out what skill sets you have internally, who your partners might be, how to structure the right relationships to make that happen. It's just a little more involved than I think people think at the outset. And if they set it up the right way, it can be extremely beneficial. But I do think it requires thought. So I'm going to hand back over to Jo.
You're right, Maribel. It reminds me, back in the day of campus networks, right? When people were setting up campus networks, and it was a lift, and it was very expensive to do, for them. But you're right. I want to get Dan's thoughts on some of the newer commercial approaches to network security modernization. Dan, we've seen SASE be a hot topic of late. We've seen zero trust network access be a hot topic of late, where folks are wanting to, one of the goals is, sort of replace the VPN. Why do you think network security is sort of all the rage right now?
Security was always important, but it's like insurance. Nobody wants to pay for it until they really need to. And there are people are trying to market security in different ways, but security has a pretty basic set of principles that have to be followed. And it's always, for security, is what is the minimum amount of systems that have to be secured, but at the same time that we can provide reliability and resilience. So that is the big question, and how you can achieve that. Will you go through a centralized security approach, or will you go through a distributed security approach? And the pendulum swings back and forth. And there isn't a right way to do it. Again, it really depends on the enterprise, how their network is structured, or how their IT systems are structured in general. I still see from some friends that they're working on code that has been written in the 60s for the banks. And there is a rule, I forgot now whom is that rule named after, but it states that it takes the same amount of time to remove that technology as long that technology has been used. So if something has been used for 30 years, it takes you 30 years to replace it. And this is more than a single career point. So the enterprises will be doing things cautiously, and they will not, unless it's a new enterprise, but if it's an established enterprise, it will take them time to do things, and they cannot adopt new technologies or new security mechanisms as they are. They have to adopt them in places where it makes sense for them to adopt it, because what might be really well working for something might not apply for another part of the enterprise, and those can be, they can be within the same enterprise. So SASE is a new way of doing it, where you establish perimeter and then everything is going through there. This is, in my opinion, similar to the DMZs, demilitarized zones that were also used as a security concept. It's just, again, we are having more compute. We can use that compute for more things, but also the non-friendlies can use that compute for malicious things as well. So it's a right layers of security that you have to approach, and that you can making sure that you're not increasing your security. So from a security perspective, you're not increasing the complexity of the system, and you're not increasing the footprint of the system.
That makes a lot of sense. And, what you're saying in terms of time for changes in technology to be implemented and then taken away also makes sense. Maribel, over to you. Did you want to just jump to our fun fact?
Sorry, I keep putting myself on mute because there's a lot of background noise here. And now I think it's time for us to discuss our fun fact. Dan, do you have a fun fact for us?
I do. I'm from Croatia, and there is something that we use in everyday's life, and it has been invented by a Croatian inventor, and it even is being adopted as a word. So that's a pen. Pen has been invented by Slavoljub Penkala. He was living in Croatia, and he patented the first mechanical pencil at the end of the 19th, beginning of the 20th century. And because his last name was Penkala, people started to use Penkala as a tool to write. And during the First World War, every U.S. soldier was issued a pen made by Penkala. So the name entered the everyday use for the writing tool.
Because Penkala, they decided was just too long, so they were just going to call it pen. I love that fact. By the way, I use pens and pencils. I'm a really big paper person, I have to admit it, even though Joe and I are all about the edge and digital. That's a great fun fact. I had no idea. See, these are the things you learn on Elevate the Edge.
Excuse me, you asked something, or because you broke up a little bit, I wasn't sure if you asked me another question.
No, I said, so these are the great things you learn on Elevate the Edge. So, Dan, thank you for joining us and for sharing your wisdom. We're really excited to basically talk to people about the changes in computing and how we're going to create a better place with edge computing. Thanks again.
Thank you. And thank you for having me.
Bye-bye.
Bye.
Thanks for listening. If you enjoyed the show, please subscribe so you can easily find us again. Follow us on Twitter at Maribel Lopez and at Digital Cloud Gal, and on LinkedIn. Links to our social profiles, show notes, and ways to listen to the podcast can be found at elevatetheedge.com.